Welcome to video 2 for this unit on probability and sampling. In this video, we're going to focus on multi-step experiments. Say we want to know the probability that it will rain every day for the next 3 days. Here is the probability of rain for each of the next 3 days. Finding probabilities for real-world events can be difficult because they are complex and not often easily repeatable. In these cases, it is useful to create a simulation. A simulation is an experiment used to estimate the probability of a real-world event. Simulations are useful for estimating probabilities for complex situations. We can set up a simulation to predict the rain situation by getting 3 bags and putting 10 slips of paper in each bag. The first bag, representing Wednesday, has 4 pieces of paper that say rain and 6 that are blank. The second bag represents Thursday and has 5 pieces of paper that say rain and 5 that are blank. The third bag represents Friday and has 9 pieces of paper that say rain and 1 that is blank. Then we can select 1 slip of paper from each bag and record whether or not there was rain on all 3 days. If we repeat the simulation many times, we can estimate the probability that there will be rain on all 3 days by dividing the number of times all the slips said rain by the total number of times we perform the simulation. Let's repeat the simulation 50 times and keep track of how many times we get 3 papers that say rain and how many times we get at least 1 blank paper. We find that there are 9 simulations in which we got 3 papers that say rain and 41 simulations in which we got at least 1 blank paper. This means that the estimated probability of rain 3 days in a row from these simulations is 9/50ths, because 9 of the 50 simulations resulted in rain 3 days in a row. Now let's look at an example of a situation where we don't need to run a simulation, but we do need to be able to list every possible outcome or the sample space for the chance experiment. Suppose there are 3 people who want to run for president of a club. There are also 4 people who want to run for vice president of the club. How many different combinations are possible? Sometimes we need a systematic way to count the number of outcomes that are possible in a given situation. We can use a tree, a table, or an ordered list to count the different combinations for this situation. For a tree, we can start with a branch for each of the people who want to be president. Then, for each possible president, we add a branch for each possible vice president. Each branch represents an outcome. For example, this branch represents the event in which B is president and 3 is vice president. We can see that there are 12 outcomes in the sample space, either by counting the number of branches in the tree or by recognizing that there are 3 groups of 4 numbers at the ends of the branches and computing 3 times 4. A table is another way to see the sample space. Another option is to use an ordered list. We can see the event in which B is president and 3 is vice president in each representation here. Let's consider one last example. Suppose we have 2 bags. One contains 1 star block and 4 moon blocks. The other contains 3 star blocks and 1 moon block. We will select 1 block from each bag at random. What is the probability that we will get 2 star blocks or 2 moon blocks? We can use a tree diagram to see all of the possible outcomes. Now we can see that there are 20 outcomes because 5 times 4 is 20. Of these, 3 of them are both stars, and 4 of them are both moons. So, the probability of matching blocks is 7/20. In general, if all outcomes in an experiment are equally likely, then the probability of an event is the fraction of outcomes in the sample space for which the event occurs. Thank you for watching video 2 of 4 for this unit on probability and sampling.